Okay, let's just have a look at kind of the start of this one. So we have a cannonball fired at a 40-degree angle. So okay, here's the horizontal. Okay, it's fired at a 40-degree angle above the horizontal. And it's fired at 140 meters per second. Okay, so it's going to follow an arc that looks like any other projectile arc we've observed. Okay, just like that. What we have to remember here is we have certain vertical information and certain horizontal information that we can calculate and that we require. Okay? The first thing we have to remember from yesterday is that the horizontal component of this launched or projected velocity is v horizontal. Okay? That will be the constant horizontal velocity of the cannonball through the entire flight. Okay, remember, because horizontal is governed by v equals d over t. Okay, there's nothing to resist the flight of the ball horizontally, so it's not going to change its speed at all. Okay, so to get that horizontal component, okay, that's going to be the cos of 40 times 140. Okay, giving us how fast the cannonball's moving horizontally. 40 is 140. Okay, so 107.246 meters per second. Okay, this angled vector also has a vertical component. What does it represent? Remember, this is the instant that the cannonball is fired. VI, exactly. It represents the vertical initial velocity. Okay, so I'm going to get that by going sine of 40 times 140. Okay, so 89.99 meters per second, and that's going to be up. What else do I know? Vertically. Gravity, right. I know the acceleration is negative 9.81 meters per second squared. We have to assume this cannon is fired on Earth because we're not told otherwise. Okay. Now, if this cannonball follows this arc and the impact point is the same level as the firing point, what do we know about VF? It's the same as VI, but negative. All right, so there's the information that we have now. Okay, let's see if you can get the rest of it, including the maximum height. Okay, you have enough information now, you should be able to move a few steps forward if you were stuck. Okay, so what's my next step if I'm going to start by trying to find the horizontal distance traveled? What else do I need? I need time. Yeah, okay. I don't have time. If I'm going to use v equals d over t, I need to have t. So I've got to look to my vertical information where I do have enough information to calculate t, okay, because I have the initial and final velocities as well as the acceleration. So I'm going to use this formula, a equals vf minus vi over t. Okay, so t will equal vf minus vi over a, and that will mean negative 89.9 minus 89.9 over negative 9.81, and that will give me the time of flight. Okay, so we're going to take that number and multiply it by 2, okay, because that's 89 minus 89, right? And then we're going to divide that by 9.81. I'm making everything positive, but obviously we would make it all negative here. Okay, so that means the flight time of this cannonball is 18.3 seconds. Okay, it's a long time for it to be in the air. It's obviously going to travel a long way. Okay, 18.3 seconds is our time. Right, so now I can calculate the horizontal displacement, okay, using v times t. So we'll take our time there and multiply it by our 107.246222. Okay, I think we only have 2 significant digits in this question. This thing flies 2 kilometers. Okay, 2.0, I think, times 10 to the 2, right? We only have 2 significant digits. So, sorry, times 10 to the 3. 2.0 times 10 to the 3. Okay, that's my horizontal distance traveled, pretty far. Second part of this question wants us to calculate the maximum height of the cannonball, which is a vertical piece of information, and it occurs right here. Right, so I'm looking for the vertical height. What do I need to remember about the maximum height of any projectile in terms of vertical information? Time is half. What else? How fast is the object going vertically at its maximum height? 0. That's the big one we have to remember. Okay? At an object's maximum height, at a projectile's maximum height, VF is 0 meters per second. VI is still 89.99. A is still 9.81. That doesn't change. Okay? But what does change is that VF becomes 0, or time is 1/2 of the 18.3 that we calculated. Okay? So at this point here, I want to find the vertical displacement, which is, okay, the maximum height. So that'll be VF squared equals VI squared plus 2AD. I could also use this formula as long as I use half the time. I'll get the same answer. I'll show you both. Okay? So I'm going to use this formula here because I like it better because I don't have to remember to divide the time by 2. Okay? I'm going to manipulate it for D. So D will be VF squared minus VI squared over 2A. Okay? So that'll be 0 squared minus 89.9 squared divided by 2 times negative 9.81. Okay. So we have 89. 0.2 squared, okay, divided by 19.60. All right, so the maximum height of this cannonball is 4.1 times 10 to the 2 meters. Right, so it's over 400 meters above ground level at its maximum height. Okay. The other way we could have done this was to use D equals VI times T plus 1/2 AT squared. Right, so if we do that, we're going to take our 89.99026,536, and we're going to multiply that by the 18.34663922, okay, and then add that to 0.5 times negative 9.81 times 18.34663922 squared. Whoop, what did I do here? Oh, because I didn't do what? See, I did this is why I don't do it this way. What did I forget to do? Divide the time by 2. It sucks this way. Forget really important things. Okay. Entry. I just want to prove to you that it does work when you're not an idiot like me. Okay. Okay. That might work. There we go. See, it does come out to the right number if you remember to divide the time by 2. Okay. So you can do it either way. Don't do it that way. Just do what I did and forget. All right. Making sense on that? Okay. Yesterday, we were talking about all these really bad movies that have incredibly bad movie physics in them. Okay, so we're gonna watch the one I was telling you about yesterday. Okay, in this one, You're trying to find the angle that the projectile is thrown at. Okay, so it's different than the last one you got. Okay, it says it's thrown into the air at a velocity of 35 meters per second at an unknown angle. Okay, so that means, okay, we've got this. We just don't know what that is. We are told what this is. Okay, 35 meters per second. We're given the time. Okay, so we got a time of 2.5 seconds. Okay, time of 2.5 seconds. And we also know that it lands 70 meters away horizontally. Okay, so that's the information in addition to this that we have. We need to find the angle at which it is thrown. Give you a few minutes, see if you can figure that out. There's actually not very much work to do on this. Okay? You basically need to do 2 calculations and you're done. The question seems tough, but there's only 2 calculations. I want to figure out what the angle is on this triangle. How many sides do I need in order to do that? 2. Right? I need 2 sides. I'm not going to be able to get the vertical side of this. Okay, remember that this side of that triangle represents the initial vertical velocity. I don't have enough information to get that. There's no way I can calculate that with the information the question gave. However, the question did give me the distance and the time horizontally. Could I find the horizontal velocity? Yeah, and then I would have 2 sides of this triangle and I'd be able to calculate the angle. Right? That's what I was saying. There's only 2 calculations to solve this. It's actually way less work than the ones we've been doing. Okay? All I have to do is calculate what V equals. So V equals D over T, 70 over 2.5. Right? And I've got 28 meters per second, okay, as this side of the triangle here. Now that I know that, now I can use trigonometry to get my angle. I have the adjacent side and the hypotenuse, so the cos of theta is going to equal the adjacent side divided by the hypotenuse. Okay, so to get theta, I'm going to go that theta equals cos to the -1, or inverse cos of 28 over 35, adjacent over hypotenuse. Okay, when I do that, okay, 37 degrees above the horizontal. So once in a while, you're going to get one that sounds really tricky, but if you really think about it, there isn't a lot of work to a question like that. Okay, this one is a head scratcher. Okay. Seems like it doesn't give you very much information. There's a bit of an algebra trick to it as well. Okay, I'm going to give you guys a little bit of time on this one. Okay, so we've got an object that's thrown into the air, and it's thrown into the air at an angle. It doesn't say that. We don't know what the angle is. We don't know what this speed is. Okay, all we know, okay, is how far it travels horizontally and how long it's in the air for. Algebra trick, and it has to do with VF and VI vertical. The launching height and the landing height are the same for this question. So think about what that means for these 2 numbers. Okay, what this question comes down to is this. I need to figure out the hypotenuse and the angle. In order to do that, I need two sides of this triangle, and right now, I don't have either one of them. Okay? But what I can remember, okay, is that this side here is my initial vertical velocity, and this side here is my horizontal velocity. All right? Can I calculate my horizontal velocity right now? Okay, so I can get one side right off the bat pretty easily. I just have to go v equals d over t, 30 over 10, and I know that this side is 3.0 meters per second. All right, that's great. That part was easy. I still need to get the other side. And it doesn't look like I have enough information to do it, except if I remember one thing. If this is my launching velocity, and this is my impact velocity, and they're level, the two velocities are, they're equal. They're equal but opposite. Okay, so here's what I want to do then. I want to look at this formula. I have A and T already. The question told me those things. VF and VI have the same magnitude, but the opposite direction. Agreed? Okay, so could I change this formula to read this instead? A equals negative V minus V over T. I mean, we just said those numbers are the same in magnitude, but opposite in direction. And that's now what I've written. These two numbers are the same number, but this one's negative and this one's positive. All right, so really what I'm saying on the top here is not negative V minus V, but that A equals negative 2V over T equals A. I've just taken a 4-variable formula and turned it into a 3-variable formula, of which I know 2 of them. So now I can solve for the one I didn't know, and I'll have this side of the triangle. And then I'll be able to get what the question wants, which is the projected velocity. So now you see what I mean by this being an algebra trick. Okay? It's not really about how well you understand projectile motion, except for realizing that this part is true. Okay? After that, it's an algebra trick. Okay? So that's going to mean then that A times T over negative 2 will equal V. Everybody all right with that? Okay, so that's going to be 9.81 times 10, so negative 9.81 times 10, so negative 9.81, or 98.1, sorry, over negative 2 is going to give me 49.05 meters per second as my V. Now that I have that, what does this tell me about the angle I threw this thing at? This side's 49.05. This side is 3. Okay? This thing is not at all like I drew it. It's more like this. 3 and 49.05. Okay? Threw it all straight up in the air according to those two numbers. That's fine. The question didn't ever say that I threw it really steeply or really shallow. Okay? I just need to calculate my projected velocity and its vector, which is just Pythagorean theorem and trig. Okay, so the magnitude is going to be 49.1, okay, meters per second. And actually, it's just going to be 49 because I think we only have 2 significant figures here. So 49 meters per second, and then the angle is going to be opposite divided by adjacent. So we're throwing it at 87 degrees above the horizontal, so effectively straight up in the air. Okay? It's not going to go very far, that's for sure. Okay? It's not very often that you're going to encounter a question that's radically different from the ones we were doing yesterday. I'm just showing you some different applications. Okay? But like I said, last year the General E question was the projectile motion question on the unit exam. Okay? So expect that I'm probably going to ask something very similar to that type of question this year. Okay. This one's also a little bit different. Okay, this one rolls off an incline 30 degrees above the horizontal with a velocity of 12 meters per second, and it lands 1.4 meters from the incline. How far above the ground is the end of the incline? Okay, so effectively what it's saying here is this. Okay, you have an incline of 30 degrees, okay, that the ball is going to roll off at. So this one's not projected upwards, it's projected slightly downwards. Okay? Does that really change anything? It doesn't really change anything. It's just our VI isn't going to be positive now, it's going to be negative. Okay? This whole thing still works the same it did before. Okay? This is still a 30-degree angle, okay, below the horizontal this time. This side's still VI, this side's still V horizontal. Okay, just our path is going to look like this, okay, instead of an upward and then downward arc. Okay, give you a few minutes on that one. Okay, so the way we solve this is actually no different than the way we would solve any of the other ones we've dealt with. We break it up into its vertical and horizontal components, okay. One of the things they tell us is that this distance here from the base of the incline is 1.4 meters. Okay, that's a horizontal distance, and that's all the information that we're given. All right, so our horizontal distance is 1.4 meters. Okay, and from a vertical perspective, we know acceleration is negative 9.81 meters per second squared. Okay, VI can be calculated by going sine of 30 times 12, which is 6 meters per second, and that will be negative. Okay. Okay, and the other thing is that we don't know our displacement, right? We only know that part there. Right. Okay, so this is what we have. So it's going to fall at 9.81. We have VI. Okay, what else do we need here if we're going to find the height of the incline? Okay, we need time maybe. Okay, if we could get that, and we also, and I think we can get that because we can calculate this as well. Okay, we have that triangle, and we can use the horizontal information to get our time. So we're going to go V horizontal, okay, is going to be the cos of 30 times 12. Okay, so that side's going to be 10.392 meters per second. Okay, now that I have V and D, I should be able to calculate the time that this thing is falling. So T equals D over V, okay, that'll be our 1.4 meters horizontally divided by our 10.392. Okay, that'll give us our time. It's not going to be very long because it wouldn't take something very long to fall off of a table or something like that. Okay, so we're going to have our 1.4 divided by our answer there. That was our V. Okay, so 0.135 seconds. Okay, that I can bring over here. Okay, so in this case, VF and VI are not equal, are they? Okay, they can't be because the object only falls. It doesn't go up and then come back down. Okay, its impact point is below its launch point. Okay, so VF and VI are not equal here. But now I have A, VI, and T. I should be able to calculate the displacement vertically using that formula, which we used a lot when we had objects going horizontally off the table. Okay? In this case, it doesn't go horizontally. We actually do have a VI. So we'll have our -6 times 0.135 plus 1/2 times negative 9.81 times 0.135 squared. Negative 6 times our answer plus 0.5 times negative 9.81 times our answer squared. Okay, so the displacement is going to be 0.8, actually 0.90 meters. Right, so it's 90 centimeters tall effectively, okay, at the bottom of that incline. Okay. Are all the principles for these all the same though? Okay. Regardless of what I ask you to find or how I twist one of these, okay, in the end it always comes down to I have a vertical component, horizontal component, okay? I can use V equals d over t for the horizontal, it's accelerated motion for the vertical, okay? It always comes back to the same ideas, okay? Regardless of how tricky I might make it. All right, give this one a try. It's review from the other day, just thrown horizontally, okay? Objects thrown horizontally 10 meters per second from the top of a 90-meter building. Calculate the distance from the base of the building that the object will hit the ground. Okay, that's the answer if you want to check and see if you got it right when you're done. So for this one here, guys, we got that projected horizontally. Okay, they tell us it's 10 meters per second, right? From a vertical perspective, acceleration is negative 9.81, although it doesn't need to be negative, meters per second squared. Okay, VI is 0 horizontally. Okay, sorry, and D is 90. Horizontally, all we know is V. 10 meters per second. So we're solving for t using our vertical information, bringing it over there, and finding the distance from the base using v equals d over t. Okay? Tomorrow, you have a quiz. I will post it at the end of the day today. But also remember that your vector assignments are due tomorrow. Okay? Get those done already. Okay? Your quiz tomorrow will be 1 horizontal, 1 angled projectile. Okay? And they will not be anything